All right, hi. This is Brian. I want to look at some of the tools in StatCrunch that are useful for giving you descriptive statistics from sample data, as well as some of the data visualization tools. First off, we're going to look at a frequency table here. This table for these 5 different classes, also known as bins. We have a frequency count. This is actually in thousands, but so this is counting how many people in our sample gave had an age that was in each of that range. So let's open this up in StatCrunch and just see how we can visualize this. So I want to take this and create a what we would call a histogram, or in fact, in this one, because we already have the bins labeled, I'm going to create a bar plot for this with summary data. I don't have the original data, I have the summary data. I have categories and I have counts. And so what I'm going to get, I'm going to order them by the worksheet order just to make sure that the order is consistent. And so you can get a nice little visualization of your data. Now, suppose you want, rather than the frequency, the count, you wanted to have a relative frequency, which is what proportion of your respondents were in each of these categories. That's easy to do, and you just change the type of chart from a frequency to a relative frequency. And you also can click this value above bar option, which it doesn't give you the values for a small window, but if I just make it a little bit bigger, as soon as it's large enough, then all of these values appear. So not only is this going to give you this relative frequencies, you can see the y-axis has been changed to the relative frequency, but also you get the relative frequencies above the bars. So you have a nice, you can take those values and you can fill in a relative frequency table. Now this is, we have time series data. For all of these months, we have closing price of a stock. So I'm going to open this up in StatCrunch and show how you can create a time series in StatCrunch. So there's a nice tool for graphing a time series. What I'm going to do is choose under graph this index/time plot. I choose closing price to be my data that I want to graph, and I want to go down. I'm going to choose time to be my x-axis, and I'm going to choose it to go by month. Starting month is 1, which corresponds to January, and the increment, that's 1 month per bar, or each data is in the next month. That's what I want. I'm going to display points and lines, and if I hit compute, it's going to give me a very beautiful time series plot. And from this, I can compare to the charts that are given here, and we can see that this is the chart that matches very nicely with the time series that I've created. So that's the right choice here. Let's see, a discernible trend, I would say that there's a general increase over time. So it generally increased over the course of the year. The percent change from January to December. To find the percent change, what we want to do is first find what was the change. Okay, so take the January and December price difference, so 37.25, that was the December price, minus 28.61, 8.64, that was the price difference. Now what I want to do is find what percent of the original price is that. So divide it by 28.61, and let's multiply it by 100 just to put it into a percent. 30.199. Now I'm going to round it to the nearest tenth, so that's 30.2%, and that's how you find the percent change. Now let's look at what we would call like a one-dimensional data set. What we have here is 15 respondents from some survey. How many hours per week do you spend? How many hours per week do you work outside of the home? And let's open this in StatCrunch and let's play with the data a little bit. All right. So first what I want to do is I want to visualize the data. I'm going to show you a couple ways of visualizing it. First is with a histogram. The histogram it's the same as what we were creating before. I want to create a frequency histogram. I can set the bins to, like these charts, they start at 0 and every new bar begins after 5 units. So I'm going to start it at 0 and I'm going to have the bin width at 5, and I'm going to hit compute to get my frequency histogram. So there we are. You can see right away that this matches, well, maybe it's not so obvious that it matches this because the y-axis is not scaled the same. But if I changed, if I want to say compared it to this, and if down here we have options to change the y-axis. We can change the scaling to go up to say 6. And if we do that, then you can see this shape is very, very much the same. So choosing the right histogram is one thing. You can also, again, we can edit this and change it from a frequency to a relative frequency histogram. We can show the values above the bar. That can be very handy. But let's look at some other data. Let's look at actually let's first see how we could visualize this with a box plot. Box plots are also handy for finding outliers from your data set. So what I'm going to do is I'm going to check this, use fences to identify outliers, and click compute. The box plot shows you 5 pieces of information plus some additional to if there's outliers. The box that you have, this large rectangle, shows you a box going from the 25th percentile to the 75th percentile. So this box represents the middle half of your data. So the 50% of the data in the middle of your distribution. So the lower bound is called the first quartile. The upper bound here is the third quartile. And this line in the middle is called the median. That's the 50th percentile. So half of my data is below that, half of it is above. The line going down is called a whisker, and it ends here at the minimum value and the maximum value. Those are if there were any data points that were considered outliers, they would be represented as dots, individual dots, but there are no outliers in this data set. So the line in the whisker goes out and stops at the last data value that is not an outlier. So I'm going to show you how we can do some get some summary stats, which will be handy for us. I'm going to select this column, and when I'm selecting summary stats, I'm going to check off IQR as well as skewness and mode. We have a couple others, but we don't need to use those. So let's look at all of these and just discuss what they all mean. So first off, it's going to give you n. This is the sample size. How many values are in our data set? The mean, this is the simple average. You add up all your values and divide by n, divide by the sample size. The variance, it's a kind of a tricky calculation, but it's easiest that you let StatCrunch do it for you. Standard deviation is the square root of variance. The standard error is not so applicable, so let's not worry about that right now. The median, that's, like I said, it's the 50th percentile. It's where the line was in our box plot here. That's the line in the middle of our blue box. The 50th percentile, half of the respondents below 17, half of them above. The range is the difference between the maximum and the minimum values. First quartile and third quartile, those are what I said were in here, the lower bound and the upper bound of that box. And then the IQR is the range between the third quartile and first quartile. So you take the third quartile minus the first quartile, you get the interquartile range. Skewness is a measurement of how skewed the data is. Now, if skewness is if it's very negative or very positive, we would say the data is skewed. But if it's close to 0, and I would say negative 0.2 is close enough to 0 that I would say this distribution is pretty symmetric. Furthermore, and you can see that from the picture that there's only a little bit of asymmetry in this histogram, but it's very, very slight. So I would definitely say this is a symmetric distribution, not skewed. A skew to the left is really what you'd see in choice A. That's a skew to the left. If your data trails off with a long tail in to the left or to the right, that's a skew. So let's see, we can, and the mode is the most common response in our data set. It's the most common value. And sometimes there'll be more than one mode, but in this data set there's a single mode, and it's at 22. Okay, so let's see, we're asked to fill in some of these descriptive statistics. We're asked for the mean, asked for the median, it's 17. What is a better description of the center? I would say, since it's a symmetric distribution, we would want to use the mean and standard mean to describe center, and we would use standard deviation to describe spread or dispersion from the mean. If we have a skewed distribution, then the median and the interquartile range are respectively a good description of the center and the dispersion. All right, now we're going to look at two sets of data, and we want to compare them side by side. So I'm going to show, we open this data set in StatCrunch and show you first how we can get those descriptive statistics very easily for two sets of data side by side. Let's go to Stat, Summary Statistics column, and what we can do is hold down the control button, or you can actually click and drag and select them both in blue, and we can compute summary stats for both of them. And we're just going to get 2 rows in our output table, and we can use that to fill in this problem. So we're asked for the mean of the financial stocks. That's right here, 3 decimal places, so that's 22.257, round up. The mean for energy stocks, 15.003. I have to round up 3 decimal places. The medians are given over here, 17.585 and 14.865 respectively. The higher mean rate of return, that's kind of an obvious question once you have it. Financial stocks have a higher mean, and the financial stocks also have a higher median. The sample standard deviation of the two, let's see, rounded to 3 decimal places for the financial stocks, 14.473, and then we have 5.334 rounded off. Riskier. What does it mean to be riskier? Riskier is more volatility or variability. So the higher the standard deviation, the higher the variability. So although the financial stocks had a higher rate of return, they were also much, much more variable. Their standard deviation is almost 3 times that of the energy stocks. Now, that was some descriptive statistics, but let's look at some visualization. Let's look at side-by-side box plots. So I'm going to select them side by side, and I'm also going to check fences to identify outliers just to see if there are any outlier months. Okay, so here's a picture that you can see you can compare the energy versus financial. You can see that we've got a much smaller range for the energy stocks, much bigger for the financial stocks. There were no outlier data points because the fences go out and up to the max and the min for each of the two. And remember, this compares the medians, not the mean. If you want to, you can add the median to the chart by checking this marker for the mean. Sorry, the mean, and so this is showing the mean and the median. Looks like for energy stocks, the mean and the median are almost the exact same because that black line is covered by the green line, but the mean for financial stocks is much higher. And actually, that's going to be because the stock price is skewed to the right. It's skewed to the higher values, whereas energy stocks looks much, much more symmetric. So a longer whisker, a longer tail on this side means that we have a skew. All right, so what I want to do is take a probability distribution and create a histogram. We can actually take a probability distribution and we can create a probability calculator for it. So if I wanted to, I can graph I would do this as a bar plot with summary data, where the category values are X and the counts are in PX. And that's all I really need to do. Hit compute and you'll get your bar chart. Now, bar chart's not exactly the same as a histogram, but we can't really compare. We can't make the bars wider, but we can choose which of these matches. And you can clearly see it's this first one. So now we can also get now what I want to do, however, is calculate the mean and the expected value, or mean and the standard deviation of this. To do that, I'm going to actually go under the Stat menu, under Calculators, and choose a custom calculator, where my values are in the X column and my weights are in PX column. And hit Compute. We're going to get a very similar chart, but this is going to give us some ability to do some probability calculation. So we can, so this actually gives us the mean and the standard deviation of this probability distribution. And that's exactly what we're asked for. The mean is mu of X. So I'm going to just type that in to 1 decimal place. That's 2.5. And standard deviation is over here. So what does the mean? The mean says that the long-term average of this probability experiment is the mean. So as the number of experiments increases, the average of our sample should approach the expected value or the mean. So that's what we're saying. As the number of experiments increases, that's what we would expect for a long-term average. What is the variance? So variance is the square of standard deviation. It's giving us the standard deviation. We have to calculate variance. So variance is, we take the 1.355, I'll put in all the decimal places, oops, 0144, and I'm going to square it. That's going to give me variance, and that's what I need to type in here. Sigma squared is variance. 1.83. Oh, it only wants one decimal place, 1.8. Standard deviation is given to me directly, so I can type that in. One decimal place is 1.4. I have to round it up. Beautiful. Notice this probability calculator allows us to calculate probabilities. What's the probability that somebody had fewer than 4? 4 is obvious. What's the probability? It was, say, equal to 3. Hit compute, you get that probability. What's the probability? It was greater or equal to 2. Click that, and it gives you the total probability is 0.763. So the probability calculator is super handy, and it's a great way of taking a probability distribution and putting it into a tool that you can use for calculations. So what I'm going to show you in this one is how we can create a probability calculator from scratch. Okay, so in this problem, I'm given, there's a few different possibilities of the amount of profit. So I'm going to call the first column profit, and the second column is probability. We're told that if the investment is strong, it will get a profit of 50,000. If it's moderate, the investment will be a profit of 20,000, and if the economy goes in recession, it will be a loss of 50,000. So say there's so that the different options are 50,000, 20,000, and negative 50,000. So we're told that there is a probability of 0.20 that there will be a strong economy, 0.70 of a weak economy, and 0.10. And those are the probabilities and the different profits. So to calculate expected value, I'm going to do just what I did before and go under Stat Calculators. I'm going to create a calculator, a custom calculator for the probability distribution that I've just put in. The values in the profit column and the probability in the probability column, or the weights in the probability column. And this is what we get. So this calculates for us the mean and the standard deviation for this probability distribution, so we don't have to calculate it by hand. So there's the expected profit, and then the standard deviation on profit is $25,000. So that's great. So this is some of the tools that are really handy for descriptive statistics and some and calculation of expected value. And I hope you enjoyed. Bye.